Hi everyone, welcome to Unit 4, Lesson 3, Write in Scientific Notation. So in the last lesson we learned how to estimate and then the basics of setting up that scientific notation. Today we're going to talk about it without the estimation first. Okay, so a couple really important things to know, to understand, and to write down. So if I were you, I'd pause this video right now and write all of this down because that's honestly some of the most helpful information. Okay, so right here, scientific notation form, that's where you have a number A, right? In this case, the A is just a variable, okay, times 10 to a power, where A is between 1 and 10, okay? It could be 1, all right, but it can't go up to 10. So notice that 1 is less than or equal to A, okay? Meaning A is greater than 1, but it can be 1, but A is also less than 10, okay? So this first number, it should only have one place value. It should only have the ones place in it, okay? And then 10 to nth power, which that is signified by mostly the place value and how far you move your decimal, all right? So this right here, this is going to be extremely helpful for us today. If you move your decimal place to the left, your exponent, in this case n, will be positive. If you move your decimal place to the right, your exponent will be negative. Okay, so going to the right signifies smaller and smaller numbers. Going to the left represents bigger and bigger numbers. All right, so let's go ahead and get into it. Here's example number 1. 0.000456 in scientific notation. So here's our goal, okay? I'm going to move my decimal to where I have one number in my place value. One number in the ones place value is what I should have said. So to do that, I'm going to move it 1, 2, 3, 4 times, because by doing that, by moving it 4 times, I'm left with 4.56, right? And remember from up here, A has to be between 1 and 10. So 4.56, that's between 1 and 10. And the next thing I need to notice is that I moved, sorry, my dog thinks she's tough today. I moved my decimal to the right, which means my exponent is going to be negative. And how to determine what your exponent's going to be? Well, first off, the base is always going to be 10. Okay, a lot of that is based off of the fact that we work in a base 10 system. I went over that in the beginning of the last video. And then I'm going to have a negative exponent. And then the number that's right here, that is determined by how many times I move my decimal. In this case, 4. So this right here, 4.56 or 4 and 56 hundredths times 10 to the negative 4, is the same thing as this number here. Okay, this is it. This is your final answer. All right, let's try it again. Number 2, 5.1 times 10 to the 7th in, we're supposed to write it in standard form. Okay, I was a little lazy with writing out the questions today. I hope that's okay with you. So right now it's written in scientific notation. We want to write it in it's written in scientific notation right now. We want to write it in standard form, or also known as decimal notation. Okay? So to do that, what we're going to do, we're going to take whatever this value is, so 5.1, and then I'm going to move my decimal 7 spaces. Being that this is positive, that means I want to get a bigger number. So that means I'm going to go to the right. I'm going to go 1, 2, 3, 4, 5, 6, 7. So now my decimal is going to come way over here. Well, what do we do with all those empty spaces? We put zeros in. Okay. Now, we moved it once over to get past the 1, so that counts as that first move. but then we have 6 zeros after that. So now I can rewrite it as, let's see, 2, 3, 4. Okay, so that would be in standard form or decimal notation. To place your commas, you start over on the right and you count over 3. Count over 3. So 5.1 times 10 to the 7th is the same thing as 51 million. Okay, so I hope that helps. Here's number 3, 671 million in scientific notation. So now we're going the opposite direction, okay? Let's see. Oh, I totally lost my train of thought. I was going to say, both of these are from your quick check. So I'm doing 2 out of 5. That's pretty awesome. All right, so what I'm going to do, if I want to turn this into scientific notation, first off, whenever the decimal is not listed in a number, it's understood that it comes after the final place value. And remember, my goal is to go 1, 2, 3, 4, 5, 6, 7, 8 times over, because I only want a number that is between 1 and 10. So in this case, that would be 6.71. It's always going to be times 10. And then the exponent is determined by how many times we moved our decimal, which in this case, what was, I think it was 8. 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the 8th. Now, one thing I should have said back here, okay, for these is, this is for going from decimal notation to scientific notation. Okay, so that's a pretty important point as well. And number 4, suppose an average person blinks 15 times per hour. How many times does the average person blink in a year? Well, there's a few things that we need to figure out, and there were some more details or hints that are listed on this problem in your quick check, but it says 15 times per hour, but our final answer is in a year. So, the very first thing that we need to do is we need to figure out, well, how many hours are there in a year? And that's going to help us figure out how many times we sneeze. Okay? No, not sneeze. Oh my goodness. Blink. Holy moly, that would be so much sneezing. Okay. So 15 times per hour, but we need to figure that out in a year. So first off, we could say 15 times 24, right? There's 24 hours in a day. And so this would tell me how many times we blink in a day. And how many days are there in the average year? There are 365. So by multiplying all of those together, we can figure out how much the average person blinks. I'm going to use my calculator on this one. We got 15 times 24 times 365. Look at that. That's a big number. That means we blink on average, except for I'm always getting stuff stuck in my eye, so then I feel like I'm blinking more. Alright, that's how many times we blink on average in a year. But, and I think the final question was to write it in scientific notation, so let's practice that too. Alright, it wasn't just a word problem. So remember, if the decimal point isn't in the number, it is assumed that it comes right after the number. My goal is to get my decimal way over here so that it is a number between 1 and 10. So in this case, that would be 1.314. Remember, it is always times 10. And then this is determined by how many times I move my decimal. 1, 2, 3, 4, 5. Okay, and being that it was a bigger number, right? It wasn't like already way off into the decimals. So that's another way that you can understand that the exponent is going to be positive. Okay? So I hope that helps, and if you need more, just let me know.